Time has always been imagined as a river, a current that sweeps every star, every atom, every fleeting thought into tomorrow. Yet, what if that river has already run dry? Picture a clock, its hands suspended mid-tick, galaxies still spiraling, but no longer moving. A universe, vast and glittering, frozen in a single frame. And within that stillness, consciousness continues to drift forward, like a dreamer wandering inside a painting. This is the paradox, whispered by physicists and philosophers alike, that time itself may be over, not destroyed, but completed. The universe, then, becomes not a flowing story, but a sculpture, an eternal structure, in which every event that ever was, or ever will be, simply is. If true, our sense of movement through time is only an illusion. Memory gives us the sensation of a past, anticipation paints the feeling of a future. But beneath those impressions lies a cosmos already finished, a book already written, with every page pressed in place. What does this mean for existence, for choice, for the fragile hope that tomorrow can be different from today? Perhaps free will is a candle flickering in a glass dome, light dancing but flame unmoving. Perhaps the end of time has already come, and we are merely experiencing its afterglow. And so the question lingers. If time is finished, what remains of the universe, and what remains of us? Chapter 1: Discovery Phase. Time, for much of human history, was imagined as something absolute, a silent stage upon which the cosmos performed its grand play. To the philosophers of antiquity, time was eternal, steady, and indivisible, an ever-rolling river that carried the universe forward. When Isaac Newton raised his quill in the 17th century, he gave this intuition its first mathematical form. In his Philosophia Naturalis Principia Mathematica, he described time as a universal constant, flowing equably, independent of the world it measured. Newton's time was the metronome of reality itself, impartial, invisible, and absolute. Every star, every falling apple, every human heartbeat was synchronized to its eternal beat. For over 2 centuries, this vision of time reigned unchallenged. It seemed unassailable, reliable enough to guide the movements of planets, strong enough to predict eclipses, precise enough to send cannonballs across battlefields. The world trusted Newton's time the way it trusted the solidity of the earth beneath its feet. But at the turn of the 20th century, the ground began to quake. New experiments whispered a troubling possibility that time, as Newton had described it, was an illusion of simplicity. The seed of doubt came from light itself. In 1887, Albert Michelson and Edward Morley designed one of the most precise experiments in history. They sought the ether, the invisible substance through which light was thought to travel, much as sound needs air. Their interferometer was designed to measure Earth's motion through this cosmic medium, but the results were baffling. No matter how they turned their instrument, the speed of light remained unchanged. It was as if light cared nothing for the motion of Earth, nothing for the presumed background in which it should have been swimming. The universe seemed to whisper that something deeper was at work. When Albert Einstein published his special theory of relativity in 1905, he placed that whisper at the center of reality. He abandoned Newton's stage altogether. There was no universal time, he declared. There was only space-time, a seamless fabric that intertwined the three dimensions of space with a fourth, malleable dimension, time. And in this fabric, simultaneity dissolved. Events that seemed simultaneous to one observer might not be simultaneous to another, moving differently through space. The cosmic clock fractured into countless local times, each bound to the perspective of the one who measured it. Time, once universal, had become personal. The full strangeness of Einstein's revelation would not be appreciated until years later, when astronomers lifted their gaze from the blackboard to the stars themselves. In 1929, Edwin Hubble, peering through the Great Telescope at Mount Wilson, made a discovery that would unravel humanity's deepest assumptions. He observed that galaxies were not static, fixed jewels on a dark dome, but were rushing away from us, their light stretched to longer, redder wavelengths. The further a galaxy lay, the faster it seemed to recede. The cosmos, it seemed, was expanding. This realization carried a radical implication. If the universe is expanding now, then in the distant past, it must have been smaller, denser, hotter. Extrapolate far enough back, and one reaches a singular moment, a cosmic birth, where both space and time themselves must have emerged. Time, the eternal backdrop, was no longer infinite in the past. It had a beginning. The Big Bang model, developed by Georges Lemaître and supported by Hubble's observations, shattered the last remnants of Newton's eternal universe. The cosmic river had a source, a first moment, a beginning of beginnings. And in that realization, a question lingered like an echo. If time had a birth, could it also have a death? In 1949, Kurt Gödel, a mathematician famed for his incompleteness theorems, introduced another shock to the fragile conception of time. He discovered a solution to Einstein's equations of general relativity, a universe that rotated as a whole in Gödel's rotating cosmos. The geometry of spacetime allowed four paths that looped back upon themselves. A traveler following such a path could return to his own past, arriving at the very moment from which he had departed. Time, in this mathematical world, was not linear. It was a loop, capable of folding back on itself. Cause and effect became entangled in paradox. The arrow of time could be bent until it pointed backwards. Einstein himself was unsettled by Gödel's universe. He admitted its mathematics were sound, though he doubted whether nature truly behaved this way. Yet, Gödel had revealed something profound. The equations that governed reality did not demand that time behave in the way human intuition expected. Time, once thought to be the most fundamental and reliable of all concepts, was revealing itself as fragile, strange, and contingent. Other hints began to accumulate. In the 1960s, the discovery of the cosmic microwave background, the faint afterglow of the Big Bang, confirmed the universe had a fiery origin. But this also suggested that time itself was tied to the expansion of the cosmos. Should the expansion cease or reverse, time as we know it might lose its meaning. Meanwhile, physicists studying the strange world of quantum mechanics noticed something unsettling in their equations. While space appeared naturally in their formulations, time often did not. The laws that governed electrons and photons described probabilities, not progress. In the deep mathematics of the quantum realm, the river of time was absent. These whispers accumulated into a troubling chorus. Time, the most familiar dimension of human experience, was revealing itself as elusive. Perhaps it was not a river, flowing independently of all things, but a shadow cast by deeper laws. Thus, the discovery phase unfolded, a centuries-long unraveling of certainty. From Newton's eternal metronome to Einstein's pliable spacetime, to Hubble's expanding cosmos, to Gigel's looping geometries, to quantum mechanics' timeless equations. Each step revealed that time was not the absolute stage it once seemed, but a fragile construct woven from the very dynamics of the universe. The mystery had been planted. If time could begin, and if time could bend, then perhaps, in some unfathomable way, it could also end. The story of time was no longer a tale of permanence. It had become a question, hanging above humanity, like a riddle written across the stars. Chapter 2: Scientific Shock. The idea that time could one day end is more than a scientific curiosity. It is a rupture in the very logic of existence. For every civilization that has ever gazed at the heavens, time has been the one certainty, the unseen foundation upon which life and thought unfold. A universe without time seems unimaginable, for without it, cause and effect unravel. A seed no longer becomes a tree. A star no longer collapses into a black hole. A life no longer moves from birth to memory. But as the 20th century deepened, the fabric of science began to whisper something profoundly unsettling. Beneath the surface of equations, beneath the observations of galaxies and the ticking of atomic clocks, time itself seemed to falter. It no longer looked indestructible. It looked fragile, perhaps even destined for an end. The story of this shock begins with the arrow of time. In the late 19th century, Ludwig Boltzmann and other pioneers of thermodynamics uncovered the principle of entropy, the measure of disorder in a system. They realized that in any closed environment, entropy always increases. Heat diffuses, order dissolves, structures crumble into chaos. From this law, the arrow of time emerged. Time, unlike space, had direction. One could walk north or south, east or west, but one could only move forward in time, never back. Broken glass does not leap from the floor to repair itself. Smoke does not return to the flame. Entropy, not clocks, defined the flow of time. But this arrow carried with it a terrifying implication. If entropy must always rise, then the universe itself was on a journey toward maximum disorder, a state where energy was spread so thin, so evenly, that no change would ever again be possible. This was the concept of heat death. In this distant epoch, stars would burn their final fuel. Black holes would evaporate into radiation. Matter itself might decay, and eventually the cosmos would drift into silence, an infinite stillness where nothing new could ever happen. The arrow of time, born from entropy, would grind to a halt. The universe would continue to exist, but without events, without change, without becoming. Time, in any meaningful sense, would be over. This vision shook scientists and philosophers alike. The cosmos was no longer eternal. It carried within itself the seed of its own silence. Yet even this bleak picture was not the greatest shock. For in the 20th century, as quantum theory unfolded, physicists began to encounter something stranger still: equations that worked perfectly without time at all. Quantum mechanics, at its heart, describes the probabilities of particles, the dance of electrons, the flicker of photons. It predicts outcomes with astonishing precision. But in many of its deepest formulations, time is absent. Consider the Wheeler-DeWitt equation, developed in the 1960s by John Archibald Wheeler and Bryce DeWitt. This equation was meant to describe the entire universe in the framework of quantum gravity. The shock was immediate. The equation contained no variable for time. The universe, as described by its deepest mathematics, was frozen. No past, no future, no flow. The Wheeler-DeWitt equation does not evolve. It simply is. This realization ignited one of the most profound crises in theoretical physics. If the fundamental laws of the universe do not include time, then what is this thing humans experience so vividly, so inescapably? What is the meaning of memory, of history, of change? Was time an illusion? For decades, scientists wrestled with this paradox. On one hand, human experience insists upon time's reality. Children grow, planets orbit, supernova explode. On the other hand, the mathematics that describe the foundations of reality suggest that time may not exist at all, or, at least, not in the way it is perceived. This contradiction is more than philosophical unease. Without time, science itself falters. Experiments depend on causes and effects, on sequences of events unfolding. Remove time, and remove the ability to test or even define reality. The philosopher Hugh Price has called it a troubling schizophrenia. In physics, one part of the discipline relies on the arrow of time, while another erases it entirely. Even Einstein's theory of relativity, for all its revolutionary brilliance, contributes to the disquiet. In relativity, time is not a universal river, but a local experience. A clock on a satellite in orbit ticks more slowly than a clock on Earth. A traveler moving near the speed of light experiences time stretched and warped, and yet relativity also suggests that the entire history of the universe, past, present, and future, is laid out in a vast four-dimensional space-time block. In this picture, time does not flow at all. Every event simply exists, etched into the geometry of the cosmos, like words on a page. Human beings, in this interpretation, are not moving through time. They are moving within a fixed landscape that already contains their birth, their choices, their deaths. The shock is profound. If this is true, then time has never been moving. It was never alive to end. At the boundary between relativity and quantum mechanics, the paradox grows sharper. Black holes, with their terrifying event horizons, stretch time until it halts for the distant observer. Quantum entanglement, in which particles separated by vast distances seem to coordinate their states instantly, hints at correlations that defy temporal sequence. Experiments confirm it. Entangled particles share information outside the flow of time, as though their connection belongs to a deeper layer of reality that does not obey causality as humans understand it. If physics is right, then time is not the foundation of reality. It is the consequence of something deeper, something not yet fully known. This is the scientific shock, the collapse of time as the unshakable bedrock of the universe. The revelation that what feels most real may, at its core, be nothing at all. The implications extend beyond physics into the realm of existence itself. If time is an illusion, then so too may be the human sense of moving forward, of living in a fleeting present suspended between memory and anticipation. The arrow of time, felt so viscerally, may simply be the brain's way of navigating a universe that, in truth, is static and timeless. In this view, every moment of a life exists eternally. The joy of childhood, the grief of loss, the wonder of discovery, none are truly gone because they were never moving to begin with. Each is a fixed coordinate in the structure of space-time, as permanent as the stars themselves. But if this is so, then the notion of an ending of time running out takes on a new, more haunting character. The universe may not so much end in time as reveal that time never flowed at all. What is perceived as an ending may be nothing more than the final frame in an eternal, already complete story. Scientists continue to wrestle with this duality. They probe entropy and the arrow of time, seeking to understand why the universe began in such an improbably ordered state. They explore quantum gravity, searching for a framework where time emerges from deeper processes, perhaps from entanglement itself. They test relativity with ever more precise atomic clocks, confirming again and again that time is not universal but relative, pliable, distorted. And still the paradox remains. The shock of time's fragility is not only scientific, it is existential. If time can end, then so too can all notions of progress, of growth, of destiny. The universe becomes not a journey but a sculpture, finished and unchanging, its apparent flow a trick of perspective. In this possibility lies both terror and wonder. Terror, because it undermines everything humanity assumes about reality. Wonder, because it hints that no moment is ever truly lost, that eternity, far from lying in the future, has been here all along. Chapter 3: Deeper Investigation. The more humanity peers into the universe, the stranger time becomes. What began as a comforting rhythm, the steady tick of clocks, the swing of pendulums, the rising and setting of the sun, has revealed itself to be unstable, pliable, and perhaps even illusory. Each new window opened by science seems to fracture the concept further, revealing a landscape in which time does not behave as common intuition insists. The deeper the investigation, the more fragile time appears. In the closing years of the 20th century, astronomers expected the universe to be slowing down. Gravity, the pull of matter upon matter, should have been gradually taming the outward rush begun by the Big Bang. The cosmic expansion discovered by Hubble, they thought, must be decelerating. Galaxies, though distant, should eventually yield to the pull of their mutual attraction. But when teams of scientists measured the light of distant supernova stellar explosions, so luminous they can outshine entire galaxies, the result was shocking. The supernova were dimmer than expected, their light stretched and weakened not by slowing expansion, but by one that was speeding up. In 1998, two independent research teams, the Supernova Cosmology Project and the High-Z Supernova Search team, unveiled the discovery that earned them the Nobel Prize. The universe was not slowing, it was accelerating. The galaxies were not merely drifting apart, they were being driven outward, faster and faster, as though propelled by a mysterious pressure embedded in the very fabric of space itself. This force was named dark energy. Dark energy now accounts for nearly 70% of the universe, yet its nature remains entirely unknown. It does not shine, it does not clump, it does not reveal itself through ordinary matter. Its only effect is to accelerate the expansion of the cosmos, pulling galaxies away from one another in an ever-quickening flight for the question of time. The consequences are staggering. If expansion continues to accelerate, the distant future will not be one of collapse, but of separation. Galaxies will drift beyond each other's horizons. Stars will burn out in solitude. Even information itself will be unable to cross the ever-widening gulf. Time, which seemed once to unite the cosmos in a shared progression, will fracture into isolated pockets. In the far future, observers may see only their own galaxy, adrift in eternal darkness, with no evidence the universe ever contained more time. Once thought to be a single thread is unraveling into strands that will never touch to trace this expansion. Scientists turned to the faintest whisper of the universe's origin, the cosmic microwave background, first detected accidentally in 1965 by Arno Penzias and Robert Wilson. This radiation is the afterglow of the Big Bang itself. It bathes the cosmos uniformly, a relic of the moment when the first atoms formed and the universe became transparent to light. With satellites like NASA's Wilkinson Microwave Anisotropy Probe (WMAP) and the European Space Agency's Planck mission, astronomers have mapped this background with exquisite precision. These maps are not perfectly smooth. They are stippled with tiny fluctuations, imprints of quantum ripples stretched across the newborn cosmos. From these delicate patterns, scientists can extract the very parameters of existence: the age of the universe, the density of matter, the proportion of dark energy. The Planck data reveal a universe 13.8 billion years old, filled mostly with mysteries, dark matter, and dark energy, and governed by laws that suggest a fate not of stillness, but of accelerating emptiness. Here, time itself is written into the sky. Each fluctuation is a fossil of a moment long past, carrying information across nearly 14 billion years. The cosmic microwave background is more than ancient light. It is the record of time's first moments, a silent ledger of beginnings. But it is also a reminder: the laws that govern the universe are not static. They evolve, and with them, so too may time itself. If dark energy fractures time on the scale of the cosmos, black holes warp it on the scale of stars. When a massive star collapses under its own gravity, it creates a singularity, a region where density becomes infinite and the known laws of physics dissolve. Surrounding this abyss is the event horizon, the boundary from which nothing can return. To an observer falling into a black hole, time seems to pass normally. Seconds tick into minutes. Events proceed as expected. But to a distant observer watching the fall, time appears to slow. The closer the traveler approaches the horizon, the more sluggish his motions become. At the threshold itself, his clock seems to freeze entirely. In the geometry of spacetime, time does not simply move more slowly near a black hole. It stops. The horizon is a place where time itself is severed, where one observer's future is another's eternity. Black holes reveal that time is not universal. It is contingent, warped by gravity, stretched by geometry. What is a moment for one observer can be an eternity for another. Time, once thought to be a single arrow, is fractured by perspective. Yet, the deepest assault on time comes not from gravity, but from the quantum realm. Quantum entanglement is perhaps the most confounding phenomenon. In physics, when two particles interact, their states can become linked in such a way that measuring one instantly reveals the state of the other, no matter how far apart they may be. Einstein, who distrusted the idea, derisively called it spooky action at a distance. But experiments have confirmed it again and again. Entangled particles behave as though they are one system, connected beyond the limits of space and time. This timeless quality of entanglement defies intuition. The correlations do not rely on signals traveling between particles. They exist outside the sequence of cause and effect. In some interpretations, they suggest a deeper level of reality where time does not apply, a realm of raw correlation, unmediated by progression. In recent decades, physicists have proposed that time itself may emerge from entanglement. In the emergent time hypothesis, space-time is not fundamental, but arises from the quantum relationships between particles. What humans perceive as a flowing river of moments may simply be the collective illusion created by entangled information. If so, then time is not the bedrock of the universe. It is a mirage. At the frontier of particle physics, the mystery grows even sharper. Efforts to unify quantum mechanics with general relativity to create a quantum theory of gravity have forced scientists to confront the problem of time directly. In many formulations of quantum gravity, time does not exist. Equations describing the universe as a whole are timeless. Only when subsystems are considered, when parts of the universe are measured against other parts, does the semblance of time emerge. The Wheeler-DeWitt equation, already haunting in its timelessness, is only one example. In loop quantum gravity, spacetime is quantized into discrete chunks, and time becomes a derived property of how these chunks interact. In string theory, time is often treated as a dimension that may not be fundamental, but emergent from deeper. Sympmetries. Again and again. The mathematics point to the same unsettling truth. Time is not built into the foundations of physics. It is something that arises, contingent and fragile, dependent on perspective, scale, and interaction. What then is the meaning of human experience? Clocks tick, memories fade, futures arrive. To conscious minds, time feels undeniable. But as the investigation deepens, the evidence mounts that this flow may not be universal at all, but a feature of perception. Neuroscience suggests that the brain constructs the sense of temporal passage by ordering sensory input, stitching moments into a narrative thread. The present is not a knife edge between past and future, but a construction assembled in the mind. The illusion of flow may be the way consciousness interprets a universe that at its most fundamental is static and timeless. If this is true, then time does not move. Minds do. Dark energy accelerates the cosmos into an unknowable future. The cosmic microwave background preserves the imprint of a fiery beginning. Black holes freeze clocks at the edge of eternity. Entanglement dissolves. Sequence into raw correlation. Quantum gravity erases time from its deepest laws. Each discovery pulls another thread from the fabric of certainty. Together, they weave a haunting possibility. that time, so vivid in experience, may be nothing more than a perceptual phenomenon, a veil drawn over a reality that is timeless. The deeper the investigation, the less certain time becomes. It is not the stage upon which the universe unfolds, but a shadow of its unfolding. Not the foundation of reality, but a fragile mirage born from it. And if time is only an appearance, then what of its end? Perhaps the universe has already finished, its story complete, its structure fixed in eternity. Perhaps what is called the present is merely the mind wandering through a timeless monument, perceiving sequence in what was never moving at all. The search for time's truth has led from Newton's steady metronome to Einstein's pliable spacetime, to the accelerating cosmos of dark energy, to the timeless entanglement of quantum physics. Each step has revealed not clarity, but mystery, not certainty, but a deepening question. Time, it seems, is not what it appears to be, and its end, if such a word can even apply, may already lie within us, hidden in the silence beneath perception. Chapter 4: Escalation. Mystery deepens. Time, in its most familiar sense, is a movement, a relentless passage that sweeps all things forward. But when the equations of physics are written in their most complete form, this passage disappears. The universe, according to relativity, is not a story being told, but a book already written. Its pages do not turn, they simply exist. Every event, the birth of a star, the fall of an empire, the last flicker of light from a dying sun, all are etched into the structure of spatian. This is the vision of the block universe. In this model, the past has not vanished, nor has the future yet to arrive. Instead, both coexist, already inscribed into the four-dimensional geometry of reality. To live in such a cosmos is to inhabit a frozen monument. Consciousness drifts through it, experiencing a single page at a time, but the entire volume is already complete. If this picture is true, then the word ending loses meaning. For how can time end if all of it, beginning to end, is already laid out? The future is not something to be created. It is something that already exists, as real as the memory of the past. The block universe is both comforting and horrifying. Comforting because it suggests no moment is ever truly lost. Horrifying because it erases the very notion of becoming. The paradox sharpens in the hands of quantum cosmology, in the attempt to unite general relativity with quantum mechanics. Scientists discovered that many formulations of the universe are static. Time, in these models, is absent. The Wheeler-DeWitt equation, the haunting cornerstone of quantum gravity, does not describe a universe in motion. It describes a universe that simply is. The timeless wave function of the cosmos contains all possible states simultaneously. Nothing evolves. Nothing progresses. In such a view, what is called time may emerge only as an approximation, a mirage formed when subsystems are compared against one another. One clock is measured against another. One particle's change is marked relative to the change of something else. The river of time is not fundamental, it is relational. This possibility deepens the mystery. If time is only an emergent property, then what would it mean for it to end? Perhaps it cannot end because it never truly began. It is not a cosmic entity, but a perspective-dependent appearance, like the shimmer of heat over asphalt. And yet, the human experience is unmistakable. the body ages. Memories pile into the past. Futures unfold with uncertainty. Equations may be timeless, but existence feels like motion. Between the mathematics of physics and the texture of consciousness lies a chasm that grows wider with every discovery. But there are darker possibilities still. If the block universe implies all of time already exists, then perhaps humanity is simply moving through the last chapters of an already finished story. The pages ahead are written. The end has already been inked into the structure of spectament, and in some scenarios, that ending is abrupt. The laws of quantum field theory describe reality as permeated by fields, each with a lowest energy state, called a vacuum. The vacuum humans inhabit is stable, or so it seems. But what if it is not the true ground state? What if it is only metastable, a temporary configuration poised above a deeper vacuum? This is the nightmare of false vacuum decay. In this scenario, somewhere in the immensity of the universe, a bubble of true vacuum could form, triggered by quantum fluctuations. This bubble would expand at the speed of light, rewriting the laws of physics as it swept through space. Particles, atoms, chemistry, even the very structure of space-time itself would be obliterated, replaced by a new reality governed by different constants, and no observer would ever see it coming, because the bubble expands at light speed. There is no warning. One moment, the universe continues as before. The next, everything is gone. In the block universe, this ending already exists. Humanity simply has not reached that page yet. Physicists cannot yet rule out this possibility. Calculations based on the mass of the Higgs boson, measured at CERN's Large Hadron Collider, suggest the universe's vacuum may indeed be met. If so, then existence is perched precariously, living on borrowed time. Here, the end of time is not a slow fading, but an instantaneous annihilation. A collapse not only of the cosmos, but of the laws that give rise to time itself. Even without such catastrophic decay, the paradox of time deepens with each discovery. If the universe is accelerating under the influence of dark energy, then distant galaxies will eventually slip beyond the cosmic horizon, never to be seen again. Each horizon acts as a boundary of time itself, dividing regions of the cosmos into isolated bubbles. To an observer within one bubble, the others cease to exist in any measurable sense. Time fractures, not in one universe, but in countless isolated domains. In this vision, the cosmos is a fading tapestry, each thread unraveling into darkness. Time is not a shared river, but a scattering of streams, each cut off from the others, each moving toward silence. The block universe insists all these futures already exist. Quantum cosmology suggests they are static. Dark energy accelerates their separation. False vacuum decay threatens their erasure. And yet, through all of this, the human mind insists on feeling time as a flow. Every breath, every memory, every heartbeat testifies to movement. Equations may deny it, but experience will not let go. The tension between science and perception grows unbearable. If the block universe is correct, then the future already exists. Free will, choice, destiny, all dissolve into geometry. A decision is not made. It is simply revealed on the page one is moving through. If static cosmology is true, then time never was. The cosmos is timeless, and what is experienced as change is an illusion born of limited perspective. If false vacuum decay is true, then time may end not with a whimper, but with an unannounced silence that erases everything, not just the story, but the book itself. Each possibility undermines the foundations of meaning. Each possibility deepens the mystery of what it means to exist in a universe where time, the most intimate dimension of being, may already be finished. The paradox is unbearable, yet it is unavoidable. Human beings live as though the present is a fleeting knife edge carving the future from the past. Physics insists that the past, present, and future all coexist. Consciousness feels movement. Equations describe stillness. In this tension lies the greatest mystery of all. What if both are true? Perhaps human experience of time as a flow is not wrong, but emergent, the way warmth is real, even though it is only the motion of molecules. Time, then, would be a phenomenon of scale, a truth at the level of minds, but not at the level of the universe. If so, then what is called the end of time is not a cosmic annihilation, but the point at which emergence collapses, the point at which the illusion can no longer be sustained. The block may remain, the geometry may persist, but the experience of moving through it, the feeling of past and future, may dissolve. To ask what happens when time ends may therefore be the wrong question. The deeper question is, what happens when perception reaches its limit? When consciousness no longer stitches the static into the flowing? The investigation has brought humanity to a precipice. The block universe insists everything already exists. Quantum cosmology erases time from its laws. False vacuum decay threatens to end reality in silence. Dark energy accelerates the fracturing of horizons, and through it all, consciousness insists upon flow. Perhaps the truth is this: time has already ended. Perhaps it never began. The universe may be a frozen monument, already complete, already silent. The sense of motion, of becoming, of change, may be nothing more than the mind wandering through the corridors of eternity. Mistaking the walls for a journey, the mystery deepens. The paradox escalates. The end of time may not lie ahead. It may be here already. Chapter 5: Theories and Speculations. To stand at the edge of knowledge is to stare into silence. The universe has revealed its structures, its laws, its histories, and yet time itself refuses to stand still long enough to be defined. At the heart of physics lies an absence, no clear agreement on what time truly is, nor whether it will continue forever. Scientists, philosophers, and dreamers alike have proposed answers. Some emerge from the hard soil of mathematics, others from the boundless skies of imagination. Each theory carries within it a vision of reality and of humanity's place in it. Here, the mystery of time splinters into competing frameworks. Some see all of time already existing. Some see time as a fragile phenomenon, destined to dissolve. Others glimpse cycles, rebirths, or catastrophic endings. All are visions of a universe far stranger than the flow of seconds upon a clock. The block universe, eternalism first, and perhaps the most unsettling, is eternalism, the block universe. In this vision, inspired directly by Einstein's theory of relativity, The universe is not a stage where events unfold one after another. Instead, it is a four-dimensional block, complete and immutable. Space and time are fused into spacetime, and within this geometry, every moment that has ever occurred, and every moment that ever will occur, already exists. The Big Bang, the rise of galaxies, the fall of civilizations not yet born, all are written into the same vast tapestry. Einstein himself gestured toward this view when he wrote to the widow of his friend, Michel Besso, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." In this interpretation, time does not pass. There is no cosmic becoming. Instead, consciousness drifts along a fixed path, like a reader moving through the pages of a novel. The novel exists in its entirety. Only the act of reading reveals its sequence. But if the block universe is true, then what does it mean for time to end? The answer is paradoxical. Time cannot end because it never flows. Yet, from within, conscious beings may still encounter what feels like a final chapter, the page upon which no further events are inscribed. The block universe removes the terror of the unknown. Everything that can happen has already happened, but it replaces it with a deeper horror. Freedom may be an illusion. Choice may be geometry. Emergent Tima, second vision, emerges from the quantum world. Perhaps time is not fundamental at all, but emergent. Here, time is not a bedrock of reality, but a pattern arising from deeper, timeless laws. Just as temperature is not an intrinsic property, but an average over molecular motions, so too might time be a collective illusion, woven from correlations and entanglements. One leading candidate is entropy. The second law of thermodynamics dictates that entropy, disorder, increases in isolated systems. This increase defines the arrow of time. Coffee cools, eggs break, stars burn their fuel. The arrow points from order to disorder, from low entropy to high, but the law itself is statistical. At its core, the equations of physics are time-symmetric. They do not prefer past to future. Only when billions upon billions of particles are taken together does the arrow emerge. In this view, time is like the direction of smoke rising from a fire. It is not written into the fundamental fabric, but arises from the way countless tiny events combine into a larger pattern. Others turn to quantum entanglement, when particles share information in ways that defy locality. Correlations appear timeless. Yet, out of these correlations, some physicists argue the structure of time itself may emerge. Subsystems can act as clocks for one another, their relative change producing the illusion of flowing time. If this is true, then time's end is not the extinguishing of a cosmic river, but the breaking of the illusion. When the entanglements that sustain the arrow vanish, the very sense of before and after may collapse. Heat, death, and entropy linked to entropy lies one of the oldest and most chilling visions of the future. Heat death, expand, and if entropy continues its relentless climb, then eventually all differences in temperature will vanish. Stars will exhaust their fuel. Galaxies will fade. Black holes will evaporate into faint whispers of radiation. What remains is a thin, cold fog of particles, spread so evenly that no work can be done, no structures can form, no change can occur. This is the maximum entropy state, perfect disorder, perfect stillness. Time itself would lose its arrow because nothing would be left to distinguish one moment from the next. For billions of years, the universe is filled with drama, star birth, star death, collisions, explosions, gravity sculpting new forms, but heat death is the silence after the symphony. The final rest of all things. In this vision, time does not end abruptly. It stretches into an infinite horizon, fading slowly into stillness. From the inside, it would feel like endless decay, the stars winking out one by one until only darkness remains. Cyclic time yet. Not all theories see the end as final. Some imagine cycles. In cyclic models, the universe does not march toward silence, but loops endlessly through birth, death, and rebirth. Ancient philosophies envisioned this, the eternal return, worlds rising and falling without end. Modern cosmology has found echoes of this idea. Roger Penrose's theory of conformal cyclic cosmology imagines that when the universe reaches its heat death, when all mass has decayed and only radiation remains, the scale of time and space becomes meaningless. At this stage, the frozen end of one universe is mathematically indistinguishable from the fiery beginning of another. The universe resets not by collapse, but by erasure of scale. Other theories propose bounces, a universe that contracts under gravity, collapses, and then expands again, reborn in a new Big Bang. Though evidence remains elusive, the idea offers a kind of cosmic comfort. Time does not end, but turns in circles, spiraling through eternity. If cyclic models are true, then the end of time is never absolute. It is a transition, a turning of the wheel. Every ending is also a beginning. False vacuum decayable. Among all possibilities, few inspire as much unease as false vacuum decay. In quantum field theory, the universe exists in a vacuum state, but not all vacua are absolute. Some are metastable, perched like a ball resting on a slope that seems flat but is not. If the universe is in such a false vacuum, then a quantum fluctuation could, at any moment, trigger decay. A bubble of true vacuum would form and expand at the speed of light, annihilating everything in its path. This is not speculation without grounding. Measurements of the Higgs boson mass suggest the vacuum may indeed be metastable. The universe, then, is like glass under strain, stable for now, but liable to shatter. In such a scenario, time ends instantly. There is no gradual silence, no fading. One moment exists, the next does not. Even the very structure of spacetime would be rewritten. Hawking once mused on this possibility, noting that while it is terrifying, it renders human fear irrelevant. There would be no warning, no pain, no witness. The end of time would arrive, and no one would know. The giants of thought teach of these visions carries the fingerprints of history's greatest minds. Einstein, who fused space and time into spacetime, opened the door to the block universe. His equations showed that simultaneity is relative, that time for one observer is not time for another. Stephen Hawking carried the torch deeper into the unknown, exploring the boundaries of black holes and the thermodynamics of spacetime itself. His work revealed that time is fragile at horizons, slowed to stillness as gravity bends the clock. Roger Penrose imagined cycles, universes without end, where time dissolves and re-emerges. His mathematics suggested that the death of one cosmos might carry the seeds of another, and countless others, from G. Gödel with his closed time loops, to Wheeler and DeWitt with their timeless equations, have chipped away at the mystery, revealing not a single answer, but a landscape of possibilities, connections to inflation, multiverse, and Field's modern cosmology ties these threads to still grander visions: cosmic inflation, the rapid expansion at the birth of the universe, may itself be eternal. If inflation never fully ends, then countless bubble universes may form, each with its own physics, its own timeline. In this multiverse, the end of time is local, not universal. One cosmos may freeze, collapse, or vanish, while others continue indifferent. Quantum fields underpin all of this. Fields give rise to particles, to forces, to the structure of reality. And yet, in many formulations, they are timeless. Their equations are static. What appears as time is the unfolding of states within them. Here, the universe is less like a flowing river and more like a vast landscape. Time is the path consciousness takes across it, not the motion of the landscape itself. Speculation, timeless being, so the final speculation arises. What if humans are not creatures moving through time, but timeless beings perceiving slices of an already complete reality? What if memory is not stored in the past, but is simply the perception of one layer of the block universe? What if anticipation is not about the future, but about glimpsing the page already written ahead? In this vision, human existence is not a journey, but a window. Consciousness illuminates one frame of the cosmic film at a time, giving the illusion of motion. The end of time, then, is not the cessation of existence, but the closing of the window, the extinguishing of awareness, perhaps. In some sense, beings are eternal already, not because they endure forever, but because every moment of their lives already exists, eternally inscribed into the structure of space-time. The theories diverge, but each points to the same haunting truth. Time is not what it seems. It may be fixed, emergent, cyclical, fragile, or already complete. And at the edge of every possibility lies the same silence, the unknowable, where physics collapses into philosophy. The search does not end here, but the speculations reveal how profoundly strange it is to exist at all in a universe where time, the one thing humans take most for granted, may be the greatest illusion of all. Chapter 6: Scientific Tools and Ongoing Testing. The mystery of time is not left to philosophy alone. It is pursued with mirrors and lasers, with colliders and satellites, with instruments vast enough to span continents and delicate enough to measure shifts smaller than an atom's width. Every new machine humanity builds is a question carved into steel and light. Each detector is a mirror held up to the universe, asking, "What is time?" And though the answers remain elusive, the pursuit itself has drawn humankind into the deepest corners of reality, closer than ever to the boundary where time may dissolve. LIGO and Virgo, listening to the tremors of space-time, the stillness of the American deserts and the green fields of Europe. Twin instruments listen for the faintest shudders of the cosmos. LIGO in the United States and Virgo in Italy are gravitational wave observatories, vast interferometers built to measure distortions in space-time itself. Each consists of long tunnels, 4 kilometers in length, down which lasers are fired. The beams split, reflect, and rejoin, their interference patterns capable of revealing a ripple in spacetime smaller than a fraction of a proton's width. When 2 black holes collide, or neutron stars spiral together, their violence is so immense that spacetime itself quakes. These quakes spread as waves, racing across the universe. When they pass through Earth, LIGO and Virgo detect the faint stretching and squeezing of reality. These signals are not merely evidence of catastrophic events. They are direct proof that time is not absolute. Gravitational waves slow and warp, the ticking of clocks, bending time itself in their passage. Already, the detection of dozens of mergers has reshaped astrophysics. But for the question of time, their role is deeper. They confirm that time is elastic, malleable, dependent upon gravity. Not a universal river, but a flexible fabric, as the detectors grow more sensitive, capable of hearing fainter and more distant events. Scientists hope to probe the earliest moments after the Big Bang moments, where space-time itself may have behaved differently, revealing whether time as humans know it had a beginning, or whether it emerged from something deeper, something timeless. The James Webb Space Telescope, gazing into origins far above Earth, shielded by a golden mirror and a sunshield the size of a tennis court, the James Webb Space Telescope peers into the abyss. Its mission is to look back, not across space alone, but across time, because light takes time to travel. Distant galaxies appear as they were billions of years ago. Webb's infrared gaze pierces the veil of dust, reaching the earliest stars and galaxies formed after the Big Bang. What it sees are not merely ancient lights, but ancient clocks. Each photon is a time stamp, a relic of when the universe was young. Already, Webb has found galaxies more massive and developed than theories predicted, so close to the dawn of time. These discoveries challenge cosmology's models, suggesting that the growth of structure and the very timeline of the universe may not be as straightforward as believed in a deeper sense. Webb confronts the question of whether time itself began in the Big Bang, or whether what we see as the beginning is only a transformation, one chapter of a larger story. If light reveals galaxies out of place, if cosmic history looks too accelerated, then perhaps the flow of time itself was not uniform in the early universe. Perhaps the arrow bent or unfolded differently, hinting that time is a local phenomenon, not a universal one. In its mirrors, humanity peers not only at distant galaxies, but at the nature of time's birth. The Large Hadron Collider, breaking reality open beneath the fields of Switzerland and France, lies a machine like no other. The Large Hadron Collider, a 27-kilometer ring buried deep underground. It accelerates protons to near the speed of light and smashes them together. Out of the wreckage, fundamental particles appear, fleeting and unstable, revealing glimpses of the underlying fields of reality. Here, time is tested at its most fragile level. In 2012, the LHC discovered the Higgs boson, a particle that confirmed the Higgs field, which gives mass to matter. But the measured mass of the Higgs suggested something troubling. The universe may not rest in a stable vacuum, but in a false one, teetering on the edge of decay. This has direct implications for time. If the vacuum is unstable, the timeline of the universe may not stretch infinitely. It may, at some unknown moment, collapse into something entirely different, a new vacuum with new physics in which time itself could lose its meaning. Beyond the Higgs, the collider searches for supersymmetry, extra dimensions, and signs of quantum gravity. Each of these would alter humanity's understanding of time. The LHC is a controlled experiment in breaking the universe open, revealing the conditions under which time, space, and matter themselves are woven. And though the answers remain incomplete, each collision is a reminder that time is not absolute. It depends on the fragile fields that underlie reality, atomic clocks measuring time to its limits. Not all experiments are vast. Some are small enough to fit on a laboratory bench, yet they probe time with greater precision than any other human invention. Atomic clocks measure time by the vibrations of atoms, cesium or ytterbium, their oscillations serving as nature's most precise metronomes. Today's best atomic clocks are so accurate that they would not lose a second over the entire age of the universe. With such precision, scientists can test relativity itself. Place one clock slightly higher than another, one on a shelf, the other on the floor, and their ticks diverge. Gravity bends time, even across centimeters. These experiments confirm what Einstein predicted. Time is local. It flows differently, depending on speed and gravity. There is no single universal clock, only countless local ones, each tied to its circumstances. The implications ripple outward. If time can dilate across a room, then across the universe it may fracture, slow, or warp in ways that defy human intuition. Atomic clocks are also used in the search for dark matter. Some theories suggest that if dark matter fields permeate the cosmos, they may subtly alter the ticking of clocks as Earth moves through them. Detecting such deviations could reveal not only dark matter, but whether time itself is linked to deeper, hidden structures. Here, in vibrations of atoms, humanity glimpses the fragility of time, the search for quantum gravity, where time disappears at the deepest level. The challenge is to unite general relativity, Einstein's theory of spacetime, with quantum mechanics in relativity. Spacetime is a flexible fabric, curved by mass and energy. In quantum mechanics, particles and fields obey uncertainty and probability. Each theory works perfectly in its domain, but where they overlap, at black holes, at the Big Bang, they break down. This is the search for quantum gravity, and in almost every approach, something extraordinary happens. Time itself disappears. In the Wheeler-DeWitt equation, proposed as a step toward quantum gravity, there is no time variable at all. The universe is described as a static wave function, timeless, complete. What humans perceive as time is not a fundamental property, but a manifestation of the relationships between parts of that wave function. This absence is not a failure of mathematics. It is a hint that time may be emergent, not fundamental, that what humans feel as flowing moments may be the byproduct of correlations, entropy, or entanglement. To test this is nearly impossible. Yet, every black hole merger detected by LIGO, every photon captured by Webb, every collision at the LHC is a fragment of evidence, assembled into the puzzle of quantum gravity. The search continues, because without quantum gravity, the fate of time itself remains unknowable. Competing frameworks. Loop quantum gravity versus string theory. 2 great frameworks dominate the attempt to describe quantum gravity, and with it, the nature of time. Loop quantum gravity imagines spacetime as granular, woven from discrete loops. In this vision, time may be quantized, existing in indivisible atoms of duration. There is no continuous flow, but a sequence of discrete steps, beyond which time cannot be subdivided. String theory, by contrast, imagines the universe as composed of vibrating strings in higher dimensions. Time in this framework is often treated as one coordinate among many, but the equations suggest it may be less fundamental than the symmetries of the strings themselves. In some formulations, time is not a primary ingredient at all, but emerges from deeper mathematical structures. Both theories attempt to answer the same question. If the fabric of spacetime is woven at the smallest scales, what role does time play in its weave? Is it a thread, or is it a pattern arising when threads align? Experiments are underway, searching for signatures of quantum foam, deviations from relativity, or imprints in the cosmic microwave background. Each could favor one framework over the other. Each could reveal whether time is built in or built out. Each experiment is a bet that nature will reveal her secrets if pressed hard enough. LIGO, Virgo, and soon the next generation detectors like LISA stretch ears into the fabric of spacetime. Webb gazes into the first light of creation. The LHC smashes matter to glimpse the fragile fields that sustain existence. Atomic clocks record the dilation of seconds themselves. Together, they form a grand network of inquiry, converging on the same riddle. Is time fundamental or emergent, eternal or fragile, a universal law or a human illusion? It is possible that new data will shatter old frameworks, that time itself will be revealed as a secondary phenomenon, arising from entropy or entanglement. It is possible that experiments will find hints of quantum gravity, confirming that time dissolves at the deepest level. It is equally possible that no clear answer will emerge, that time will remain elusive, slipping through equations like water through fingers. But in either case, the effort reshapes the human story. For in searching for time, humanity is also searching for itself, for what it means to exist in a universe where even the ground beneath every thought, the ticking of every clock, may be an illusion. The probes grow more sensitive. The clocks grow more precise. The accelerators reach higher energies. The universe waits, silent, indifferent, and somewhere in its silence, the nature of time lies hidden. Perhaps it will yield to instruments, perhaps it will not, but the search itself is already an answer. That humans, beings adrift in mystery, will never cease asking the question. Chapter 7, Philosophical Reflection, Emotional Close. The universe speaks in vast scales, but humanity experiences it in hours and days. The ticking of clocks, the rising of the sun, the quiet passing of seasons. Every human life is measured, not in galaxies or epochs, but in breaths, in childhoods and memories, in fleeting encounters, in days that blur and disappear. Yet behind each of these moments lies the same mystery that governs black holes and the Big Bang. The same question that unsettles physicists also lingers in the silence of human hearts. What is time? the human scale of time and earth, time takes on a rhythm that feels natural, inevitable. The cycle of light and dark, the dance of the moon, the turning of the planet. These rhythms carved civilizations, guided agriculture, and shaped myth. But the daily cycle is not the essence of time, only its local echo. Days end, years pass, generations come and go. Time is felt most powerfully in its absence, in the fragility of youth, in the inevitability of aging, in the sorrow of loss. Every human being carries the awareness, however faint, that moments cannot be reclaimed, that time only flows forward, that what is loved today will one day be gone. Yet, if the universe is truly a block, if past and future exist as solidly as the present, then perhaps nothing is lost. Perhaps every moment once lived remains etched into reality forever, eternity. In every instant, consider the possibility. If the block universe is real, then the day a child first learns to walk still exists, preserved in space-time like a page in a book. The laughter of friends long gone still vibrates, their voices written into the eternal fabric of the cosmos. From this perspective, nothing is erased. Time does not flow away. Instead, consciousness moves across a fixed structure. What appears as passing is only the traversal of awareness through coordinates already there. This transforms grief. For if every moment endures, then the beloved dead are not erased. Their moments remain, not ghosts in memory, but permanent structures in space-time, as real as the stars, and it transforms joy. Every fleeting instant of wonder, every sunrise, every embrace is eternal, unmovable, forever inscribed. To live, then, is not to chase time, but to experience eternity piece by piece. Free will and the weight of destiny. But such eternity carries another question. If all is already written, then what of choice? If the future exists as firmly as the past, then every decision has already been made, every act already lived. Free will becomes an illusion, the sensation of choosing within a story already complete. This is unsettling. Human beings live as though choice matters, as though paths are open, as though tomorrow is unwritten. Yet the block universe suggests otherwise. Still, there is another perspective. The experience of making choices, of wrestling with decisions, of moving through uncertainty. This too is real. It is woven into the fabric as surely as the outcomes themselves. Free will may be illusory, but the experience of freedom is part of the design, a necessary texture of consciousness. And if time is eternal, then perhaps destiny and freedom are not opposites, but two sides of the same pattern. What has been chosen was always meant to be chosen. What has been lived was always meant to be lived. Humanity, against the cosmic backdrop, beyond the abstractions, lies the simple fact of existence. Against the backdrop of galaxies colliding, stars burning out, and universes expanding into silence, humanity is small, a flicker on a cosmic scale. Yet that flicker is not meaningless, for if every instant is preserved, then each life, no matter how brief, is a permanent addition to the structure of reality. A single heartbeat is written as indelibly into spacetime as the birth of a galaxy, the block universe, the heat death, the false vacuum decay. These are vast concepts, but their resonance is intimate. They remind humanity that even the smallest moments are not lost to oblivion. They are part of eternity. The fading of stars. One day, far in the future, the stars themselves will burn out. Galaxies will drift apart, their light fading into cold darkness. Entropy will spread until nothing stirs. And yet, even then, the record of existence remains. The story of Earth, of humanity, of fleeting moments of joy and sorrow, all remain etched into the architecture of spacetime. The stars may vanish, the galaxies may scatter, but the wonder of being will not be erased. For in the block universe, there is no true end. There is only the fullness of eternity, already complete. Wonder as eternal. Perhaps this is the final resonance of the mystery, that while science seeks equations, humanity seeks meaning, and both converge upon the same realization, that time, whether fundamental or illusory, cannot diminish wonder. The human mind, fragile and finite, dares to contemplate infinity. It dares to ask whether time itself is real. In doing so, it leaves a mark as enduring as the stars. And if time has already ended, if all moments are already complete, then wonder itself is eternal. The final reflection. Imagine the last light of the last star flickering in the far future. Imagine galaxies stretched so far apart that no signal can pass between them. Imagine silence filling the universe, and within that silence, imagine a truth that every moment has always been eternal, that the laughter of children, the falling of rain, the quiet gaze at a night sky, all remain forever. Perhaps what humans call time is only the unfolding of awareness through eternity. Perhaps existence has never been a river flowing forward, but a cathedral already built, each stone a moment, each arch a memory, each chamber an experience waiting to be entered. And if so, then nothing is lost, not one life, not one breath, not one instant of love or sorrow. Closing imagery. The stars fade, but the story remains. The galaxies drift, but the record endures. And even as time itself may dissolve, human wonder persists. The quiet awe of beings who once gazed into the sky and asked, "What is time?" Perhaps the final answer is simple. Perhaps it has always been before us. If time has already ended, then it was never time we were moving through. It was eternity itself.